All right, I'm Ryan X. Charles, founder and CEO of MoneyButton. I'm here joined with Steve Shadders, who is both the CTO of InChain, and you have another title which I can't remember right now. What's your title with the Node software?
Technical director of the Bitcoin SV node project.
Okay, so Steve, we were just talking about the new spec that you guys have for the protocol update, and this interesting part of the spec, which are the different types of rules there are, where you clarify the difference between Bitcoin rules, consensus rules, local policies, standard policies, and then valid, invalid, rejected transactions. Do you want to maybe just do you want to explain what is this all about? What is the spec about, and what is this?
The spec in general is a definition of the changes that are being made to the current incarnation, I suppose, of the Bitcoin protocol. The whole purpose of Genesis, of course, is to return the Bitcoin protocol back to the one that Satoshi specified in the white paper, and was further described in the original code that he released. It's a tricky process because there have been a bunch of features and other rules, etc., added over the course of the last 10 years, and so we've had to find safe ways to revert a number of those. But through that process is actually when you're working out how to do something like this safely, the process itself has a tendency to clarify certain ways of framing and thinking about Bitcoin, I guess. So much so, in fact, that there's a common term, I suppose, called consensus rules that it appears in the white paper even, that has been used throughout the last 10 years to group together a collection of rules that we had to come to understand through this process. The categorization is not quite so clear cut, and in fact, even Craig himself has looked at the sort of distinction, I suppose, that we've had to draw between these two categories of rules within the consensus rules, and agrees that there actually is a need for a clarification, I suppose, of the terminology. So previously we've talked about consensus rules and policy, and the broad distinction between those two is that a policy rule affects what transactions a miner will choose to mine into a block themselves. It doesn't affect what transactions they will accept in a miner, in a block that is mined by another miner. Those rules are what we refer to as the consensus rules. So if a block is received by a miner, there may be transactions that follow that exceed certain limits, or there might be various other limits in terms of number of transactions or block size, etc., that are beyond what that miner would choose to mine themselves, but they will still accept them as part of the valid blockchain. I think through this sort of process of working through the removal of various limits and how we do things like deprecating P2SH, etc., it's become clear to us that there are actually a couple of categories of these rules, of these consensus rules. And we've broken them up, and we've actually explicitly defined them in the Genesis spec as the Bitcoin rules and the consensus rules. And I suppose I would characterize the distinction between the two. The simplest way to characterize the distinction between the two is a term that's very common in computer science: immutable and mutable. Immutable means cannot be changed, and it's a term that's probably well known in Bitcoin, because once something is recorded in Bitcoin, it's considered immutable. That record can't be changed. Mutable, of course, means you can mutate it, you can change it. And so it really sort of brings to light an interesting kind of new way of looking at the Bitcoin protocol, because it really is made up of these rules that cannot be changed. And let me give some examples. the fact that the value of the inputs must be equal to or more than the value of the outputs of a transaction. That's an immutable rule, because if it wasn't there, then you could literally just create new money every time you made a transaction. The amount of new Bitcoins that can be minted by a miner when they mine a new block, that is an immutable rule, because the inflation schedule of Bitcoin was defined at the beginning. And in fact, Satoshi used the term set in stone. And I believe that he was referring to this particular class of rules, of which there are several more. Now jump forward to the other category, the consensus rules. The most famous of these is the block size, which is a limitation that was not actually in Bitcoin at the beginning at all. Satoshi was persuaded to put this limit in place as a countermeasure to a spam attack, because way back in the beginning, Bitcoin was worth almost nothing. So transaction fees also were worth almost nothing. There was nothing stopping someone from, flooding the network. And the vast majority of these consensus rules are actually, if you look at them closely, they reflect limitations in the capacity of software or hardware. The maximum maximum block size rather, whether it be 1 megabyte or 512 megabytes or 10 gigabytes or petabytes, there is always going to be a practical limit to what hardware can handle. Now, Satoshi wanted those limits to be pushed constantly, and this is part of the reason why orphans were actually built in as part of the protocol, and they're something that we embrace rather than fear. Orphans are the mechanism for poorly equipped miners to basically get a kick in the ass and told, if you want to keep up with the network, you need to upgrade your hardware so you can actually handle blocks that are bigger than, or as big as everyone else can. So these are sort of limitations. They're almost configuration values. Let's just stick with the block size as the example. And miners can push them up, and they can push them up. And if one miner gets too far ahead of the pack and they don't have a majority of hash power, then they will end up getting forked off and they'll get punished. But if they pull enough miners behind them, then the ones that are sort of at the low end of the spectrum, who can't handle the big block size, they'll get forked off. And if they're in the minority, well, their chain kind of dies. So these consensus rules are almost designed to be managed by Nakamoto consensus. A majority consensus basically determines what the acceptable range of those limits or what those rules are.
Okay. So all this is, I feel compelled to create a bit of context. Like this is kind of an interesting conversation in light of the whole history of how we got here. I mean, there have been many debates over the rules of Bitcoin throughout the history of this project. And these things really matter when it comes to like what can miners actually change and what can't they. So it's helpful to clarify some of these things. So let me just, if I could maybe ask a few particular questions, like you mentioned things like, okay, so certainly one of the Bitcoin rules is that the value of the inputs must be equal to or lesser than the value of the outputs, because in other words, that means you can't just print money unless it's in a Coinbase transaction. Would be the one exception to something like that, where by definition, Coinbase transactions can have outputs greater than the inputs. So there's like that's a Bitcoin rule, and that's very central because it would ruin the economics to allow that to be changed. But there are other rules that are consensus rules that the miners sort of have to agree to some extent, although I'm not sure I'm getting this right, but so block size being the other big one. That is a consensus rule in your definition, right? But it's clearly or at least in the vision of Satoshi, as I go back and read what Satoshi wrote originally, certainly it strikes me that the idea is to allow that to be, to grow somehow, that there wasn't originally a maximum block size at all. So those are two examples, but let me think of other ones. So something like, what about things like the language, script, for example? So what would constitute, like, what is a Bitcoin rule in script? Like, presumably the way these operations are defined must be fixed, something like check sig. I mean, imagine if the definition of check sig could change, you could really change the meaning of what a Bitcoin transaction is and what it does and stuff like that. So that's probably an example of something where the definitions of opcodes is probably a Bitcoin rule. Is that correct in your opinion?
I think the definitions of opcodes, yeah, they are, and unfortunately, some of those are ones that have been subject to change over history. Because I mean, I guess one of the highest guiding principles that the Bitcoin SV team has used since its inception is to preserve the economic integrity of the Bitcoin blockchain. We should never make a change that makes a spendable output unspendable, or vice versa. And to change the signature rules is something that would very much do that. Yeah. In fact, I mean, we're going so far as to make the old signature hash algorithm that was removed when BCH came into being. We're going so far as to make that valid again, to ensure that any offline transactions that were made before BCH days can be spendable. Yeah. So, yeah, I think the definitions of opcodes would fit into that rule. But having said that, I mean, there's a fairly kind of new way, I guess, of framing things and thinking about this. So I haven't had a chance to sort of take this framework and apply it to every single rule within Bitcoin. So right. I'll say that as a caveat, that I might make one or two mistakes in the course of this conversation in terms of how
Well, because I'm looking at it right now, and I'm just trying to see, because like basically the spec is it's detailed because there's a lot of information in here. But I also suspect that basically it could be vastly longer if you tried to make it completely accurate. I mean, basically the task of coming up with a precise spec sounds extremely daunting to me.
Actually, this is a really important point, because I have previously made an attempt through Enchain to develop a Bitcoin spec. And I think that the way that I did it the first time around, it actually was quite a substantial amount of work was done on it, but it never quite got over the line to being complete. But I do think my approach to that the first time around was wrong, because I took as gospel the idea that has floated around Bitcoin world for quite some time, that the Bitcoin spec is whatever the reference client does, including all the bugs. Now that is actually really bad architectural practice, because I can see why that statement and why that definition was made. In the first place, it was to avoid potential catastrophes and unexpected chain splits, but it's really not a good way to define a protocol. Because what you're doing there is you're actually intermingling a definition of the way something is intended to work with the implementation details of how you've made it work, which necessarily include limitations that probably can't make it work the way you intended to make it work. So when you say this spec could be a lot longer, certainly it could. I think it could probably be 10 or 20 times longer if we went into painful detail about how things are actually implemented and what are all the edge cases, etc. But those edge cases themselves aren't necessarily a part of the Bitcoin protocol. Those edge cases might mean that the Bitcoin SV node just can't do something that another implementation of Bitcoin SV can do, and the way that you resolve that incompatibility is through Nakamoto consensus. So those rules, if you actually went so far as to define them, at best would be considered consensus rules and not Bitcoin rules. Probably I would actually consider them to be local policy rules, which is another step down. You know, those are the rules that are applicable to me as a node, what I will try to build blocks on. If I'm incapable of accepting and validating a block that the majority of the network can produce and validate, then that's my problem. It's not a problem of the Bitcoin protocol.
Okay. Yeah. That's very interesting. Okay. Let's see. So I guess a way I see what you're saying is something like it's actually better if we were to write. So this is a spec for the upgrade. Is that correct? This isn't an attempt to be a spec for Bitcoin exactly. It's a spec for Genesis. Is that correct, or are you making an attempt to make a spec for Bitcoin?
No, its scope is explicitly limited to the changes to the protocol that we're making in the Genesis change. However, it's a little bit grey because normally when you would make a change spec, you would refer back to the baseline spec. So you'd have this is what we're actually starting from, and this is what we're changing to end up with this result. We don't actually have that kind of original spec. So it really does highlight the urgent need for a proper Bitcoin spec. But I think one of the things that I've kind of gotten excited about through the process of building this, putting together this spec, and I should credit everyone else who was involved. Daniel actually did the majority of the work on this, not myself. But with these definitions, there's the notion of separating the consensus rules, which are a reflection of the software implementation, not a specific description of the software implementation, but they do reflect the limitations of the software implementation. Separating those from the Bitcoin rules makes a Bitcoin spec so much more feasible, because it actually narrows the scope of the protocol spec itself down to a quite digestible and reasonably understandable thing. And in fact, as I've been thinking about it over recent weeks, that spec itself, if you applied a filter and converted into slightly more formal language, would be the Bitcoin white paper plus a few other details that you would probably extract from the original kind of version of Bitcoin. So I think it's a very doable thing to create that spec now, and it's something that we need to do very soon.
Yeah. Okay. So that is okay. So there's a lot in this, but the basic ideas I'm gathering from you, I mean, it's really important to recognize the difference between sort of the protocol and the software. And you have this idea that if you were to write down a sort of, let's call it a high level protocol spec, where you're deliberately not writing down the implementation details, is relatively achievable. That this would be things like we said earlier about the inputs being greater than or equal to the outputs. It would probably include things like, well, you validate a transaction by running these scripts, which are this Forth-like programming language and so on. And it would be detailed in the sense of explaining to you how it works, but none of the implementation details. So nothing like whatever standard script rules or something like this, whatever, anything, I wonder, you would probably have to still have some details though, because presumably things like the structure of a transaction. So you'd have to, you draw a line somewhere and determine what's an implementation detail and what's not. But it does make it sound much more accessible. Like the higher level it is, you could really write that down and it would be pretty clear, I think. Especially if you said, you could even clarify things like using your new language here, Bitcoin versus consensus and all this stuff. What's your third one here? Bitcoin rules versus consensus rules versus local policies versus standard policies. Clarifying the role that the maximum block size plays, which is different from inputs being, greater than or equal to outputs, as the sort of canonical example there. Anyway, that's very, go ahead.
I just wanted to clarify, local policies is actually another name for, actually, no, I'm looking at the spec right now and I think I'm telling you a lot. I was going to say, I thought local policies was the name that we decided to use to replace standard policies. Yeah, local policy, I guess policy in general is, we decided to prefix the word local there to emphasize the fact that it is a rule that is applied just inside one Bitcoin node and
Okay.
not across the network.
Okay.
But you just reminded me, I think, of a really interesting example of this, and I think Kurt, don't sure how to pronounce it, Kurt Walker Jr. For prompting this thought in some of his recent thoughts about mempool. It's a classic example. We always refer to the mempool as the bunch of transactions that haven't been confirmed yet. And it's a classic example of in the naming itself of mixing up an implementation detail with a definition of what the thing actually is. What the mempool is a collection of transactions that are not confirmed yet in a block. And I think a better name for them is the unconfirmed transaction set, which neatly marries up with the, the unspent transaction set. The mem part of the mempool indicates that it's in memory. That's an implementation detail. There is nothing about the mempool that requires it to be stored in memory. It could be stored on an SSD drive. It could be stored on tape. You could write it down on paper if you wanted to. You could actually write a functional Bitcoin node by writing the transactions down on paper and still sort of sit within the spec. Yeah. And so it's that kind of conflation of implementation detail with definition of protocol that it really does cause problems. We've seen it many times over the years with people kind of confusing implementation concepts with the protocol itself.
Okay. All right. So let's see. I'm kind of browsing through the list here. Is there anything else about the details about it that you want to talk about? I mean, I think the high level is the most interesting thing. I mean, basically clarifying the distinction of the different types of rules. I don't know. Is there anything in the details that you want to talk about? Anything else about the spec that we didn't cover already?
Yeah, maybe a couple. So, I mean, we went into Genesis with the goal of removing all limits. Some of them, very, very few of them, but a couple of them are simply not practical to remove just yet. I need a little bit more work on the implementation level to kind of make it safe for them to remove. But it's important to point out that all of those ones are limitations, which means almost by definition they're consensus rules, so miners can actually move those around at a later date without needing hard forks or anything like that. Another important one to point out is that we've actually introduced a new consensus limit. I know that might sound like crazy and completely antithetical to the philosophy of getting rid of the block size limit and whatnot, but it's basically it's a memory-based limit that enables nodes to make a choice if someone. Sorry, before I go there, I should define what that is. The limit is maximum script memory usage, the maximum amount of memory that a single script can actually use in terms of what it's put on the stack. And that's a very, very clearly defined calculation so that it can be replicated across nodes no matter what your implementation is. And the reason for that is simply that if you remove all of the limits and the bounds on script, you can create scripts that consume insane amounts of memory and probably can crash any kind of a node, no matter how big the hardware. So there needed to be a way for nodes to agree that this is how much I can actually tolerate, and if the script uses more than that, then I'm not going to mine it into a block. But just like the block size, what we've done there is we've made the default value for that unlimited, So miners actually have to step up and set that value themselves, and then manage it properly using the the Nakamoto consensus mechanism, which is made easier with miner ID, etc., because they can then publish what their settings are, and other miners can look and work out a way to make sure that they don't accidentally fork themselves off. The last one that I think I will talk about, there's plenty of others, but it's probably the one that will garner the most attention, I think, is the deprecation of beta script hash. Beta script hash is the mechanism that almost everyone in BTC, BCH, whatever, currently uses for multisig. The original version of multisig, which we refer to as bare multisig, is actually almost impossible to use on BTC and BCH now, and in fact right now is difficult to use on BSV as well because of standard policy rules. We're getting rid of those in the Genesis upgrade. And pay to script hash was kind of a way around that. So from many people's point of view, pay to script hash is the mechanism for multisig, and if you take it away, you can't use multisig anymore. I just want to make the point that, well, I want to make 2 points. One, we are not making a multisig or pay to script hash, existing pay to script hash outputs unspendable. If you have an existing multisig wallet, you do not have to sweep your wallet into a new one. You're not going to have your money suddenly become unspendable. Nothing like that is going to happen. You'll be able to use it going into the future. You just won't be able to receive new funds into it. Having said that, there are other mechanisms for multisig, including the original one that was in Bitcoin, and an even better one that we've actually developed an end chain called Accumulator Multisig that has even better privacy features than pay to script hash does. So there's probably going to be a lot of FUD out there about the fact that we're deprecating pay to script hash. Along the lines of your funds are going to get burned, or you won't be able to use multisig anymore. Neither of those things are true. We actually reached out to a number of exchanges and said, if you use multisig, Enchain actually stands ready to do the coding for you, to update you, so that you can use the new mechanism or the old mechanism, the original mechanism. To date, aside from the debacle with BitGo, who demanded $15 million from us to support it, and as Calvin said, he told them to go F themselves. We actually haven't had any significant, or I haven't actually had anyone else come to us and go, this is a problem for us. So yeah, I think it's an issue that you can make a big media story out of, but isn't really one. And Electrum SV is actually planning on having support for new versions of multisig by Genesis anyway. So.
Okay, all right, yeah. I mean, all that makes sense to me. It's one of those things where I don't know what the end users are thinking. So I used to work at BitGo. It's a funny bit of history there. That so for them to, I mean, basically what they must be thinking is, so they're not going to support. I think they've decided to not support BSV at all anymore, because their platform is basically completely dependent on P2SH. Everything about the way BitGo works is P2SH. So probably what they're thinking is, in their mind, it makes sense to just drop support rather than, figure out how to change their platform. So that just shows you something about what their thinking is, because many of the people, and this is non-technical, it's a bit of a tangent, but I'll keep it brief. I mean, many of the people involved in the cryptocurrency industry, of course, have a very different vision than BSV. Their vision has morphed into this idea of many different blockchains existing simultaneously. So if that's their vision, the ones that for BitGo, given the way their platform works and that they are intrinsically dependent on P2SH, they don't like the idea of supporting one that doesn't have P2SH anymore. So they just have this world of everything that supports P2SH, I guess. So anyway,
in fact, it goes further than that. I think Bitcoin addresses themselves are a problem here, which is something that we've tried to attack directly with Paymail, and there's no painless way of doing this. So I absolutely agree with your assessment that they want a platform that works across many different cryptocurrencies, and of course it's not going to work for them with Paymail because we're not going to let them use it on any other any other cryptocurrency. But I'll make a point with BitGo. I did actually speak with several people at BitGo, including their CTO, and we made the offer. We said we will come and do all of the development work for you. Obviously, there might be some secure systems you don't want us to touch. We can advise you on that, etc. So, I mean, the cost to them would have actually been, quite minimal. There might have been a little bit of integration work. So, I don't think there was any real intention there to.
I mean, this gets to potentially private, but that's very interesting to me that you talked to them and gave them that offer too. I mean, where in the world does this $15 million figure come from? It sounds like outrageously high to me. I don't know. Is that, you don't have to talk about this, but I'm just curious. It's unrelated to the technical things, right? I mean,
I'm not sure where the rest of it came from. I was initially told it would cost them $3 million to integrate it all, and at that point was when I made the offer and said, "Look, I didn't say I think that's bullshit, but I did in my mind." But I said, "Look, we'll do as much of the work as possible for you." It was a later conversation that term morphed into. We'll need $3 million a year for 5 years or something like that. I don't recall the precise detail, but
well, I'll give another. I feel compelled to give like my sort of business side of this, which is that it would be very funny if MoneyButton ended up competing with BitGo, because from my perspective, what happens is by exiting BSV, basically they're creating a business opportunity, whether it's for MoneyButton or another wallet company or something like that is another story, but it creates an opportunity for us. Whether we do that or not is kind of a different question, but really it's just interesting. It shows you something about what they're thinking as a business to do that.
Certainly, and we've actually had others who are probably competitors to BitGo reach out to us subsequently, and are very keen to kind of integrate that technology. I don't think it would actually be very hard for MoneyButton to do it at all, and of course the particular IP that I'm talking about is OpenBSV, so I would be more than happy to facilitate MoneyButton integrating that and becoming a multi-sig custodial service if that's what they wanted.
Makes sense to me. Okay, so we're getting off on this sort of non-technical thing. I think we can probably try to keep it slight. Well, although probably the non-technical stuff is probably pretty interesting to people. Anything else we should talk about with?
We shouldn't do too many deals on YouTube, I suppose.
Anything else we should talk about with this? I mean, we've covered a lot. I mean, there's so many particulars. I'm hesitant to go further into the details just because it starts getting unbelievably technical. I don't know. Anything else that we should talk about with respect to this upgrade and these rules?
I think we can draw a line under the Genesis upgrade, because otherwise this will go on for another hour or two. Yeah. But there's probably one point that someone actually pointed out to me on Twitter from the last time I spoke to you, which is worth mentioning, which is something very close to your heart: the ancestor limit, the 25 change transactions ancestor limit. Mm-hmm. So when we spoke last, I think it was the day after Brad had just started doing some tests on SDN, and he did those tests in a far more thorough way than I actually thought that he was going to do. And we've kind of come to the conclusion that raising it immediately to 50 is the very safe option. We think that 100 is actually probably okay, but I think that what we'll be seeing in the next few days might be, I don't want to preempt announcements, but we might hear from one or two miners that limit is going to be bumped up to 50 with the advent of Merchant API and Miner ID, which are entering beta like right now. we might find that if you use the merchant API mechanism to submit transactions, that we might be able to bump that limit significantly higher. So our ultimate goal is to get rid of it completely, or at least to raise it to something ridiculously high, like 1,000 or 10,000 in the short term, until we can get rid of it completely. But hopefully that should be some good news for app devs, that we can at least sort of double the limit and maybe quadruple it.
Okay, well that makes a huge difference. I mean, every minor increment to that makes a difference for sure. So that's very good to hear that. So yeah, I guess that's a reason for all of us sort of wallet developers to look into the merchant API, and this sounds like probably the first reason for us to use the merchant API. Will be again, I hope we're not preempting announcements or something, but this is what I gather from you. But that we'll be able to use that to have an increased limit there. So yeah, that sounds great. Sounds very interesting and very useful.
I'd love to be able to deliver an unlimited limit, but alas, there are other limits on what limits we can unlimit. In terms of how much time we've actually got to get Genesis done. But,
well, even a small, it's like it's a small increment is a lot better than nothing. So it will make a noticeable difference, because people still encounter this issue all the time. So that's, I mean, even a small one is important. So that's really good. Okay, all right. I think that it sounds like we probably covered everything. And as you're saying, we should probably keep it limited to this subject matter. We can go on forever. So, Steve, great to talk with you. Thanks very much for the information. I hope this is useful to the people in the community. And wonderful to talk with you. And thanks for your time.
Thanks for your time as well.
All right, great.